Okay, number 57 has us launching a ball at a 45-degree angle, and they tell you that it goes 98 meters. And they want to know with what speed do they launch the ball. So whenever you're dealing with a projectile motion problem, what you do is you break it down into the vertical and the horizontal components. Now vertically, what you do, you have the initial velocity, the final, the acceleration, time, and distance. Horizontally, you've got a velocity, distance, and time. So the thing that's screwy about this problem is that what you're supposed to do is break it down into its we're looking for the you're supposed to break this into the horizontal and the vertical components. But the thing is, they don't give you this, so you can't break it down. That's actually what they're looking for. But what's really nice that this is a 45-degree angle. So whatever, I don't know what this is. I'll just call it x for lack of a better variable. But whatever that is, so is this. So I'm just going to label those two things as x in this equation. So, and you'll see how this comes to help us in a little bit. But just knowing it's a 45, 45, 90 triangle, I just know whatever they are. Once I find these, I can use the Pythagorean theorem to figure out what v is. So I'll just call this x. So that's my initial velocity vertically. And it's also the velocity horizontally. So they're both x in this case. What I'll do is I'll say that the final velocity here is 0. The acceleration is negative 9.8. I don't know how much time it takes to get right here, so we'll call this time t. Now it's really funny because I have two unknowns, and that's okay, because what I'm going to do is I'm going to develop two equations for my two unknowns. Because remember, horizontally, the time that it takes for it to get right here, the time it takes to get to the whole thing is 2t. And the distance we know is 98. So these are the things that we know. The horizontal distance is 98. Whatever the vertical and the horizontal speeds are the same, and the times are related. So what we have is two unknowns. We don't know x, and we don't know t. So what we're going to do is I'm going to make an equation out of all this stuff. Vf equals Vi plus At. I'll use all the stuff that I was given. Vf, 0. Vi is x. The acceleration is negative 9.80. And the time is t. Over on this side, I can develop an equation with velocity is equal to distance over time. The velocity being x, the distance is 98, and the time is 2t. So now I've got it, and I'm basically done from here on out. Now it's all algebra, because I've got two equations with two unknowns. I don't know t and I don't know x. So you guys know a lot of ways to solve this. Like you could use substitution. You could graph them both, see where they cross. You could use a matrix. I think those are probably about the major ones that you guys know. But the easiest one is probably substitution. So what I'm going to do, see how this is already solved for x? So what I'll do, I'll move the x over here, and I get negative x equals negative 9.80 t. Then I'll just make these negatives into positives. Because they're both. So then what I'll do is I'll take this and plug it into that. So I get 98 over 2t is equal to 9.8 t. So then what I'm going to do is solve it for t. So I'll bring the 2t over, and I get 98 is equal to 19.6 t squared. So t squared take 98 divided by 19.6. I get 5. That's nice. And then so t, I take the square root of that, is 2.24. And this is not my answer. I mean, it's too bad it wasn't asking for how long it was in the air, because it was in the air for 4.48 seconds. Remember, this t is how long it took to get right there. So what I'm going to have to do is plug this back in. So I'm going to take this back into here, and I'll say x is equal to 98 divided by 2 times 2.24. So if I take 98 divided by 2 times 2.24, I get 21.9. And that's what x equals. So this x that I just solved for, I'll put this back over here. This is 21.9. And so is this. So I know both of these pieces. To be 21.9. So what I'm going to do is use the Pythagorean theorem. I'll say 21.9 squared, a squared plus b squared equals c squared. So I can take a squared, and it comes to 30.9. So I probably gotta go 31. And that's my final answer, 31 meters per second.